we have a couple more things to talk about to finish up section 4.4. I'd like to start with this homework problem. I think you know how to do it. You might want to try pausing the video and see if you can get the answer yourself. If we're given g of x equals e to the x, then g of ln of 4 is just e to the ln of 4, right? We replace the x with ln of 4, and so we have e to the ln of 4. And then the important point here is that this is a natural log. This is a log base e, and this is a base e exponential, and so they cancel. The e and the ln cancel, and we're just left with an answer 4. Okay, so this idea that that the exponential and the logarithm cancel each other out, that they're inverses of each other, is important. It was important in the last section. We have a reminder here, and we'll use this fact again in the next two sections in the rest of this chapter. Okay, the other thing I wanted to talk about was the change of base formula. It says that we can take an expression like log base a of x, where a is any base, right? Remember, a has to be positive and a is not equal to 1. But the nice thing here is that we can change that to the base of our choosing, and here's how we do it. We can rewrite log base a of x as the common log of x divided by the common log of a, since we like base 10 so well. We also like the base e, so we could also rewrite this as the natural log of x divided by the natural log of a. Or in fact, we could choose whatever base we want. And so we could write this one more way. We could write log base b of x divided by log base b of a. Again, the bases that we're really interested in are base 10 and base e. So I don't see why we would we don't have any immediate use for any other base than those. But let's see the example here. Our example will be to evaluate the log base 5 of 17, and we'll need a calculator to do that, right? That's going to be that the answer is not an integer, but in order to put that into the calculator, we need to convert it to either a common log or a natural log. So so maybe if you didn't notice that before, well, let's just look right now. On your calculator, you'll have a button for a natural log, for a base e, and also for a base 10, but not for any other base. So if you want to evaluate an expression like log base 5 of 17, then the key is to use the change of base formula. And so we could write this as the common log of 17 divided by the common log of 5. Or we could write this as the natural log of 17 divided by the natural log of 5. Either one would be fine. And they'll both give us the same answer, and we can come over and look at that calculator and see what it is. So if we type in the natural log of 17, and we divide that by the natural log of 5, then our answer is right here, 1.7604. And I will invite you to use common logs instead, and to verify that you still get the same answer. So to 4 decimal places, 1.7604. Let's write that down. 1.7604. Okay. One more thing I'd like to do is I would like to show you why the change of base formula works. So this is nice to understand in its own right, and then it's also going to be important in the next section when we solve some more equations. So what I've just said is that the log base 5 of 17 is the same as the log of 17 divided by the log of 5. And here's how we're going to demonstrate that that's true. So what we're going to do is we're going to let log base 5 of 17 equal x. We'll just call it x. And then we can rewrite this as an exponential. And we could do it immediately. We could write base 5 raised to the x is equal to 17. Or we could even show an extra step to justify that. We could write 5 raised to the log base 5 of 17 equals 5 to the x. And you've seen this before. The 5 and the log base 5 cancel, and you're just left with 17 on one side and 5 to the x on the other side. Okay, so if we start out with log base 5 of 17 and we call that x, that's the same thing as 5 to the x equals 17. And so now what I'd like to do is I'd like to take the common log of both sides. So I'm going to take the common log of 5 to the x and the common log of 17. And it may not be initially obvious why I would want to do that, because in the past we emphasized having the same base in the log and the exponential, and now we don't have that, right? The exponential has base 5, the log is a common log. There's a base 10 there, and we can write it in if we like. Maybe better if we don't, if we just remember that it's there. So at any rate, we have a property of logs which says that if I have the log of an exponential, then I can bring that exponent down in front. So this was one of the property of logs that we studied in section 4.3. It says I can write the x, I can write the x down in front, and I'd have x times log of 5 is equal to log of 17. And then can you see the last step? We'll just divide both sides. Here, let me actually let me write that step in. So now I'm going to divide both sides by the log of 5. And the log of 5 in the numerator and denominator cancel. They're on the left side, and we're just left with log of 17 over log of 5. And that's exactly what we were trying to get to. So we started out with log base 5 of 17, and we called that x. And then we went through a series of steps, and we wound up saying that x is also equal to the common log of 17 divided by the common log of 5. Therefore, the two expressions, log base 5 of 17 on the left and common log of 17 over common log of 5 there on the right, those two expressions must be equal. And we're done.